Now I want to just go more the further. What is the group is the milling for the multi-axis. So the multi-axis is the CNC machines that is the 4 and 5 axes. So here the mill planar mill contour is 3 axes, and here also we have seen the hole making group. So drilling, spot drilling, hole milling, and so on. Also we have seen the turning operations. So tomorrow also we will see also the ham turning. That's more detailed. You can also look at that lecture. So now here the multi-axis, so it's for the 4 and 5 axes. So in this case we will have the 2 additional axes. This is the 4th and 5th. So we will learn how to program this kind of CNC machine. So if you remember in the lectures, in the 5th and 4th axis milling machines, we have the 2 additional the table is the rotating table. That's the rotation of the table, 2 axes. That's the rotation of the table. We call it as a axis, and the tiltment of the spindle, then we call it as a B axis. So it is 2 more additional axes. So if the table rotates, it will be 4 axes CNC machine, and additional to this one, if the spindle, the tiltment, that with the some angle, it will be the additional axis. So the CNC machine will be the 5th axis. So in general, that you will have the 3 axes. That is the common 3 axes X and Y, and additional 2 axes. So now we will see that these 2 axes, the CNC machine, that's the called in this case the multi-axis. I will select here this one, and here the some operations that we will see. Then they are also the more or less similar, that if you learn for example one, that you can easily learn the other one. So I will just cancel this one. Here the product, and I want to just make create the multi-axis machine for this product. Firstly, as usual, here I need to define my workpiece as usual. Then the stock and the step-by-step, the coordinate system, tool, and operation. So firstly, let's define the workpiece here. In the geometry view, here the workpiece. Double click on the workpiece and go to the specify the part here. Click on this one and select the workpiece here, and just click OK. On the blank, specify the blank. Click on the blank. And in this case, just I want to use this option. We haven't seen this one. That's offset from the part. So this option is used. So it is just offset, create some offset material that is all the shape from the workpiece with some distance. If you specify the distance, for example, 1 millimeter here, you see the 1 millimeter. So it will create the offset of 1 millimeter material as a shape of the part here with this shape with all the from all sides. It will create the 1 millimeter offset, the offset material. So this is another option. So far we have seen the geometry, boundary block, and boundary cylinder. Now we use the offset from the part. Click OK. In this case, you can specify here any number. Just I put here the 1 millimeter. So click OK. So just now click OK here. So double click on the coordinate system. So I want to keep my coordinate system. It's a 0 point here. Click OK. So this is the initial setting. So now we will create a tool for the multi-axis machining. Here, create a tool. So here it is you need to select here the multi-axis, and here the available tools that is used for the multi-axis. And here for the finishing operation, as usual, we will use the ball milling with this one. Select the ball and click OK. So this is our tool as usual. Then you can define here the dimensions, the diameters of the other tool. For example, I want to make the tool with a 10 millimeter diameter here, and the tool number, let's here define as a 1. You can define the tool material as usual. I will keep here the high speed still. Just click OK. As usual, you can go to the chunk and you can create the chunk. You can create the holder as you want. So click OK. So I created my tool here. Now I will create my operation. This create operation. So we can use the any. For example, let's use this one, the variable streamline. So this is the user for the creating the program for the multi-axis. So let's use this one, first one, because you can use any of them. I will show them. Let's use the first one, this one, most commonly used. So in the location that program, the tool as usual, you need to specify here the method. Let's make the finishing operation. Then you can define here the name. By default, it is the same name of the program is a variable streamline. So click OK. So here it will be the open it, that this menu, that's the dialog box. Then you need to specify here the cut area. So this you need to go to specify the cut area, and just I want to remove the material on this surface. I will select here this surface as a cut area and click OK. And here the drive method. Here the method is the streamline, because here we selected our operation as a variable streamline. But you can change directly the drive method in the differently. If you open here, that there is several drive methods. That is that you can use boundary. You can go this. We will see that you can go to the surface area. Now it is the streamline, because we selected streamline when we are creating the program. So selecting so go to the edit, make some edit for the streamline, and here you can you can do there. You can define the cut pattern. It could be the zigzag. So that zig, it's better to make the zigzag, because you will save the time. So we will see what the zig form, also other form. So let's see here. And here, number of the passes. So if you increase this number of the passes, this is the step over. This changing this passes. So if you increase this passes, it will this step over along in this case the y-axis will be the high. So the surface finish will be the smooth. So let's keep first 10, then we will see how it will be changed if you change this value. Let's keep here these values by default and click OK. And what we can do here, project vector. You need to go to the project vector and go to the normal to the drive, change the normal to the drive. You know what is the normal? It is in the 90 degree. The tool projection vector will be the normal to the surfaces, keeping the surfaces that is normal to the drive. So it should be the normal to the drive. Then here we have the tool axis. And in this case it is the axis of the tool is the normal to the part. So it is the keeping the tool axis normal to the part. But here the several options you can open. If you open this one, there are several options, and here that this is the important. And by the controlling the tool axis, you can create the program for the 4 axes and the 5 axes machines, CNC machines. For example, here you see this 4 axis. Here the 4 axis relative to the part. Here the 4 axis normal to the part. And here again 4 axis normal to the drive, and 4 axis relative to the part. So when you see here the 4 axis, this one and this one and this one and this one, these options is used in order to program the 4 axis CNC machine. So this only the 4 options is used for the programming 4 axis CNC machine. So other options here, the away from the point, this is the toward the point, away from the line, toward to the line, and other options is used for the programming the 5 axis CNC machine. So this is the by the defining this axis of the tool, by the controlling the tool axis, you can define which kind of CNC machine you are writing the program. So if you select here the 4 axis, that will be this one. So now let's keep here the normal to the part. And so it means that we are creating the 5 axes. So it will keep the normal, but it will be the 5 axes. So we will have, if we create our the G code, we will have the 2 more the axes is the A axis and B axis is not keeping the normal to the part. So let's generate to see how the tool pass. So you see the tool pass is created. So the number of the passes, it was a 10. If you go to the here in the drive method in the streamline, so the edit, that was the 10. Here you see that this one 10, and that's why here we have this number of the passes, the 10. If you want to make here the more the accurate surface, you need to increase this one. So go to the again the drive method to the streamline, the edit. Let's increase this number. Let's make it here the 40. So and click OK, and here the generate. So this becomes the more the number of the passes. So your the surface finish will be the more the smoother. So now you can go to the simulation just to make here the decrease the animation speed. You see the tool. So here if you just click on play, so it will start to the machining. So you see the tool is moving there, and it's the 5 axes. So it is the multi-axis machining. You can see here. Now we will see our the G code. So it's the multi-axis machining. So here, let me just. So this is the finish of operation. So this is the multi-axis, and if you want to generate the G code, click your operation here. Again, click on the post processor, and here we need to select here the 5 axis because we created 5 axis the CNC program. So we'll create here 5 axis. Here the metric. Click OK, and click OK here just to see the G code. And here you can see the G code, and so here you can see this is the angle. There's the B angle here. You can see it's the additional angle here, and here so the cannot see. I can write here the another angle here. This is the Z axis, the B angle. So here the A angle. So here this is the A and the B angle. So only changing the B angle. So the angle additional angle. You see that it is the constant. That because the table is not rotating. Only the tiltment. That is the tiltment here. The B angle of your the spindle is the changing. The tool is that's the table is the fixed in the one position. So it is not rotating. Only here the one axis is the tiltment of your the of your the spindle is the changing. So there is more and other there's the axis is the X and Z, and also the obviously Y axis. It should be the Y axis also here. This one. So this is the 5 axis G code. So additional here the A and B axis. Here I will see the simulation one more time here. So here the workpiece is the fixer, just the table is not rotating. Only you see the tool, the spindle tiltment is changing with the angle here. Only the B axis. So it is the multi-axis, the one option that you can generate your the program. So let me just wait until the finish. You see that we created 1 millimeter offset. That is the stock. That is the removing that 1 millimeter, and on the surfaces of the workpiece we selected here as a specify the cut area. If I display this one, so this is the the area which in the the cut area. So you can just click on OK. So this is the first option that you can use using the variable streamline, and you can here the use the, for example, the this one, the fixed contour, or this one, the same operation. For example, let me just delete this one. So delete this operation. Yeah, the delete, create operation, and let's variable contour, the same program, and here you see that you will get here the boundary. In this case the boundary, but you can change this boundary option to the streamline, which we have done. So every time you can change here the your method here, that anytime you can change your the method and go to the specify the cut area. Again, just specify your the cut area, click on OK, and let's generate here the tool axis. So we need to change our the tool axis here. This should be the drive, normal to the drive. So again, go to the tool axis. You can now here the keeping the normal to the normal to the part. So you can go to the another operation. So now we will see the other operation. So let me keep here this one. And what you can do here, use this option, the curve point. Select the curve point. Also, you can just select as a curve that this point. Click OK, and the tool axis keeping the normal. That's the here let's keep it this one. So generate here the toolpath. So in this case, you see that we created the toolpath only along this one because we used the drive method. The drive method as a curve. So along the curve. So you can use the drive method differently. The streamline we have used your surface area and so on. And this is the curve. And if you just verify your toolpath and here just play, it will just follow this curve along this curve, just moves along this curve. So this is this option. The here variable contour that we use the drive method is curve point, but if you create operation, here we use it variable contour. But if you go to the variable streamline and click OK, here you see the drive method will be the streamline, but you can change your the drive method to the again to the curve what we have done, and again select this curve, click OK, and just generate. So the same operation. So what I want to highlight here, you see you can use any of them, but when you are using anytime you can here change your drive method. So the drive method is important here.